working. So first what you have to need is a scale. So here we have a Sartorius scale that is it's an expensive but very precise for measuring the weight of the gemstones. And then we have here a hook that is hanged on the back of the balance in the special place, and this is going in the water. So what we are going to do is we are going to weight the stones here in the air. Then I will pick that stone and I will put the stone here in the basket right in the water, and then I have the weight of the stones in the water, and we're gonna apply just the small formula we have seen. So to make this demonstration, here we have two stones. That's very nice. They are more or less the same size. One is a diamond that is nearly 1 carat, and the other stones is a simulant. So you see that it's not very easy to make the difference if you don't know. Here is not the perfect light to check the diamond, but here we are just looking to play with those stones and see which one is real and which one is fake. So I will pick one, the first one, and here you can see on the scale we are at 0. We are weighting in carat. So I drop the stones, and here we have just a little bit less than a carat. So we have 90 points. So I will just remember this. Here we have 90 points. So 1 carat is divided in 100 points. Now I take the stone and I will just drop it in the basket. And here we measure, here we have 64. Okay, so now we have here the weight in the air, and we have 64, the weight in the water. So now let's just apply this formula. So we have the specific gravity equal the weight in the air, so that it's 0.90 divided by the weight in the air, so 0.90 minus the weight of the stones in the water, that is 0.64. So let's see what that gives. So we plug this in the calculator. So first 0.90 minus 0.64, that is 0.26. So we have here 0.90 divided by 0.26. 0.90 divided by 0.26 equal 346. So here we have the 346, that is the specific gravity of that stone. So now if we are checking here in this table and we check under the diamond, we see that here we are very close. 346, here 342, over we are 363, and all the rest is over the nearly 3.5 that we have. So that is for the first stones we have. Now let's make the same calculation for the other one. So here we're taking out the other stone, and now I'm taking the other one. So the scale is at 0. We weight the stones, and here we have 165. So specific gravity, here what? 1.65. Now we are going to weight the stone in the water. So we are at 0. drop the stones on the water, and we have 1.38. So we have 1.38, that is the weight in the water. We have 1.65, that is the weight on the air. So now we're going to apply that formula again. So we have 1.65 minus 1.38 equal 0.27. Now we divide this number to get the specific gravity. So we have 1.65, that's what the weight in the air, divided by 0.27 equal 611. That is the specific gravity of the second stone. And then we see immediately that is not possible at this weight, at this density, to be a diamond. So if we check here on the map we have of all those imitation, we see we are right in the range of the cubic zirconia. So you see, for exactly the same looking stones, we have a very, very big difference in density, because the cubic zirconia, it's a very, very heavy. So it's a very, very good imitation for the diamond. But on another way, its weakness is the